In this lesson, we're going to cover nonlinear systems. And so before we go over nonlinear systems, let's just go over what linear systems were. We went over linear systems in the second, third, fourth, and maybe fifth lessons of module 1. So this is basically how pre-calculus started. So here are a demonstration of the 3 things that can happen with linear systems. So linear systems is 2 lines. More times than not, this is the most common thing that's going to happen. You're going to have one solution. These 2 lines are going to cross somewhere at one point at x comma y. And so that is the one solution of your system. These were the 2 special cases. You have no solution where you have 2 parallel lines because their slopes are the same. And so because they will never cross, they will never touch, you have no solutions. The other thing that can happen is you can have infinitely many if you have the same line on top of the same line. And so I tried to demonstrate that here with a red and green pen, and then it came out black almost, but you can kind of see the red and the green right there. And then it eventually went black when it was right on top of each other. But so when that happens, you have infinitely many because we have a point everywhere since the same line is on top of the same line. Okay. So when you have linear systems, these are the only 3 things that can happen. When we have nonlinear, we have a lot more options on what can happen. So if I look at my first example here, we're going to have to graph these equations. And I think that's supposed to be of the system. So we kind of need to identify what shape these 2 things make. Well, this is linear because you have an x to the first and a y to the first. So we do have a line here. And then here, because you have an x squared and an x squared and a positive, it's either a circle or an ellipse. And because these 2 have the same coefficient, we know that this is a circle. Okay. So let's think about what can happen if I am graphing a line and a circle. Okay. The most common thing we think of is that you have a line that goes through the circle. And if that happens, you're going to have 2 solutions right there. Now, this is probably actually not the most common thing that can happen with a circle and a line. The most common thing that's going to happen is you're going to have a circle, and then that line is going to miss it. So we could have 2 solutions, or we could have no solutions. One other thing that could happen is I could have my circle, and I could have a line that is tangent to the circle, meaning it just hits it right there on the outside. And so we could still have one solution. So when I had linear, I could have no solution. When I had linear, I could have one solution. But now I have 2 solutions. Is there any way for a line and a circle to have infinitely many solutions? No, there is not a possible way for a line and a circle to interact and have infinitely many. Okay, let's kind of look at some other shapes here. Here, if you have you have y equals x squared, so you have one square term and one term that's to the first. When you have that, you have a parabola. And then here you have x squared and a y squared, so we would say circle, but because of this minus, this one is a hyperbola. Okay, so let's see what happens when I have a hyperbola and a parabola. See how my options can change. Okay, so you have a hyperbola, and I don't know which way this is going, right? This one's going side to side. We could also open up and open down. But then if I have a parabola coming here through the middle, let's just use a different color since they're pretty similar in shape. If I have a parabola right here, this one is crossing in 1, 2, 3, 4 places. So we have 4 different solutions with this. We could have a hyperbola going like this and a parabola right here in the center. But here they're not touching at all, so this is no solution. Okay, what else could happen? We could have our hyperbola. And we could have a parabola that hits right here. At the hyperbola's vertex. So that would be 2 solutions. And we could have a hyperbola here with a parabola going in the middle and only hitting one of the vertex. Okay. And then we could have something of a combination of these two as well, actually. Here's my hyperbola. And my parabola could go through this one, but only hit the vertex of this one. So this one's actually got 3 solutions. Okay, so we have a wide range of things that can happen with a parabola and hyperbola. 5 different things. We could have no solution, 1 solution, 2 solutions, 3 solutions, or 4. And there's no way to get more than 4. And there's no way to have infinitely many, even though these do have similar shapes. Hyperbola is kind of V, right? And parabolas are U. So I don't think it can have infinitely many, but I could be wrong on that. So don't hold me to that one. Okay, but the point is we've got more than just my linear systems here. I don't think I have this one. I definitely have these 2, but it's not just one that could happen. I could have 2, 3, 4, or not 5. Okay. So keeping in mind how many times or how many solutions we could have is very helpful as we go through these. Let's just go ahead and stop the video right here. So that's going to be your introduction here to nonlinear systems. When we come back, I am going to show you how to graph and find your solutions.